Hey friends, my name's Catherine. I am going to be doing a few videos to record basically what I would be covering if I were still doing the group tutoring with Biochemistry 2. So we'll break it down by topics. The first topic is going to be just an overview. I will say that a printout of Dr. Zoe's Biochem 2 notes is a must. I think it's very necessary. I did a single-sided printout so I could take notes on the back side of each page, and it really helps you stay with combining the PowerPoints versus the whiteboard writing with the notes, which are really help synthesize all the information. So just a little, my 2 cents worth on how to start out the quarter with keeping yourself organized in Biochemistry 2. So the biggest thing really I've seen with tutoring is that overall it's not that hard to memorize a pathway. It's not that hard to memorize A turns to B turns to C, but what's difficult is that a lot of people don't have any understanding of what it means. They don't have any functional or practical application of the information. And a lot of times that falls back on these first few weeks of just introductory material and bringing back some of that Biochemistry 1 information into Biochemistry 2. So, for example, you already learned what oxidation reduction is, but now we're going to actually learn how it applies in metabolism. And a lot of people don't even know what the word metabolism means, and that's not a put down by any means. It's just like, hey, let's start there. Let's just get a good solid foundation, and then you can build on the foundation from there. Because if you don't have the foundation, it's tough to go forward past midterms. So anyways, let's go ahead and start. So metabolism, what does metabolism even mean? Everything in your body is essentially accomplished through metabolism. Every single cell in your body, and there's different estimates, but trillions of cells in your body, each one is doing some form of metabolism, whether it's, I don't know if you've looked at those huge comprehensive metabolic maps, but there's a lot of different pathways that you won't be learning in Biochemistry 2, so just always understand how intricate the body is, but all of it works together so well. And this class is just going to be your little peekaboo into that realm to kind of start understanding the body. So metabolism, the work that your cells do, from digesting your food to making your hormones and whatnot. So metabolism is basically a list of all these pathways. So everything is, to the best of science's knowledge so far, all these pathways are mapped out with substrate, or you have something, a substrate here, and an enzyme takes that, changes it, and then you have your product. And then there's another enzyme that takes that product, which is now its substrate, and creates it into a different product. And that's just what happens in all these pathways. So this quarter with Biochemistry 2, you're going to be learning 14, 15 different pathways. I haven't actually counted, but there's a lot. There's a lot of different pathways. And a lot of them actually overlap in part because they use a lot of the same components. So for example, if you're familiar with the periodic table and the elements of carbon, hydrogen, oxygen, nitrogen, those are going to be the 4 foundational elements of everything in metabolism. So there's only so many variations that you can make with that. There's a ton, I'm simplifying it. But basically that's just to say that if you have a pathway, you think about them linearly. If you have a pathway that's going down this way, or there's another pathway that stopped here and then goes that way, and another one that stopped down here and goes that way. So a lot of them kind of overlap, and I believe Dr. Zoe refers to some of those as shunts, different shunts of pathways. So we'll cover those as we go through specific pathways, but every pathway will fall under either catabolic or anabolic or amphibolic. So that's our first list here, is catabolic versus anabolic. Catabolic, you should learn with Biochemistry 1. Basically, you take something large and you break it down to its pieces. When you catabolize that, the energy that is given off it's called an exergonic reaction, or a negative delta G. Again, all these are review terms from Bio 1, so pull out your old notes if you need them. I'm going to draw a diagram with that in a moment, possibly a separate video, but basically if it's catabolic, it's exergonic, it has a negative delta G. That's just a way, different layers of describing a type of reaction or a type of pathway. Also, if that's occurring, it's typically going to be an oxidative reaction as well. So if you take glucose, for example, the way that we break down glucose is it's a catabolic reaction and we're oxidizing it. And when we oxidize, it's the loss of hydrogens, right? So oil rig, if you remember that, oxidation is losing, reduction is gaining. So if it's an oxidation reaction, it is losing, oxidation is losing the hydrogen. If it's a reduction reaction, rig is gaining, so reduction is gaining hydrogens. So then that's the flip side of it. We've talked about the catabolic or the oxidative pathways. So the other side of that is going to be your anabolic or your reduction pathways, or your endergonic or your positive delta G pathways. They're just different layers of describing the same thing. The way I tutor is I very much base it around layers. If you don't understand layers that pretty much mean the same thing, you're learning a lot of unnecessarily separate ideas when really you can just kind of combine it. So always be looking for those connection points, as well as umbrella learning. So you always need to know what your title is, what your overview or your big category is versus what are specific examples of that, because a lot of these enzymes are very similarly named, and you don't have to memorize necessarily every single one with an individual function if you understand that they're part of a category. And if you know what that larger category is, you've already described 3 or 4 enzymes. So just ways to kind of simplify your learning. So anyways, you've got your ways to describe pathways. I'll draw a diagram with that in a moment. So then another thing going forward, this is going to be bigger. This regulation topic is going to be a much bigger deal. I'll probably do a video with regulation just in and of itself. But every pathway, you're going to need to understand how it's regulated by the body. Let's say, for example, the body stores energy in the form of glycogen. So it's not that much, it's just enough to get us between meals. So let's say the body doesn't know how to stop storing glycogen. That's a bad example. The body doesn't know when to stop breaking your glycogen down when you are trying to store it. So if that's always happening, as you're trying to store it, your body is also breaking it down because there was no regulation there. So really, when it comes down to being hungry between a meal, you have no reserve stores. So you're going to go straight into breaking down your muscle. That'll be the second overview video of the organization of the pathways, when they're occurring and stuff like that. So regulation. Regulation is done via one of 2 ways. It's either something coming from in the cell or something coming from outside of the cell. If it's something within the cell, that's going to be dependent on your energy levels. So the products of metabolism, ATP, NADH, different downstream products, if they start to accumulate, it tells the cell, hey, we've got enough of this, we need to do something else. So those things can then say, hey guys, way back there, slow down. We don't need as much over here anymore. So that's one of the ways to intracellularly, meaning within the cell, communicate to slow things or to speed things up. So the other way is extracellular. Extracellular trumps, because that's the way that our body communicates as a whole between the nervous system, endocrine system, metabolism. All of it together is done via basically the hormones. So extracellular regulators are your hormones. You've got insulin. Everyone should be at least in part familiar with insulin, especially with the diabetes epidemic. Insulin's a big deal lately, right? It's a big topic, and Dr. Zoe loves insulin. So insulin is one of the ways to regulate from outside of the cell, as well as the flip side of insulin. So insulin has one job, and that's pretty much to make the body do anabolic things, or to store things or make things, so anabolic reactions. Whereas glucagon is going to be the opposite role. Glucagon says, hey, we're hungry, let's break down the protein, let's break down the fats, let's do this, to mobilize things to give your body energy when you don't have a recent meal. So they do 2 opposite things. You also need to associate epinephrine with glucagon. Epinephrine or adrenaline does the same thing as glucagon. So there's one little point with that I want to go ahead and make now. Extracellular regulators can't enter the cell. They don't enter the cell. It's kind of like I have a lot of analogies, so going forward we'll have a lot of them. But with the hormonal regulations, I always make the analogy of a room, right? And it's Someone knocks on the door, that's the hormone. They're just knocking and they're really relaying a message. They are not going to enter the house. They're not going to enter the room. All they do is knock, send a message, and then you have secondary messaging system that take the message from the door into the cell where it needs to go. So that's regulation. Every pathway is going to have enzymes, regulating enzymes or rate limiting enzymes. Go ahead and get that terminology in your head, because every pathway has 1 to 3, maybe 4 enzymes that hear, so to speak, the regulating factors. Because not all enzymes respond to regulation, just a handful of them and specific ones in each pathway. And here's another analogy for that. Think of it as an assembly line. So you have an assembly line of workers, right? Let's say that every single one of them had noise blocking headphones. So the assembly line workers are the enzymes, and as they pick something up, change it, and set it back down, that's what they're doing with the substrate, change, product, substrate, change, product. And they're workers, that's what they're doing. So that's the idea of enzymes in metabolism. And so you've got this long row of these assembly line workers, and then let's say 2 of them took their noise blocking headphones off, and they can hear the loudspeaker. So they can actually hear the boss say, hey, speed up, hey, slow down. And so those 2 or 3 or however many there are that can actually hear that, those are your rate limiters, because they'll either start slowing things down, and so things start backing up before, and they can go do something else with it, or they'll start speeding it up because we need more of that product. So that's the idea of those rate limiting enzymes. Okay, so as far as our reactions, I've already been using the word substrate and enzyme, and again, you should probably just know that from Biochemistry 1 anyways, so I won't delay there. But then we've got our transfer molecules. This right here, these last 3-4 lines right there, very important that you understand what a transfer molecule is, how they work, how they fit into the anabolic, catabolic, oxidative reduction standpoint. It's very important that you understand that. Everything is built around these here. Because in metabolism, the point is to get the hydrogens off of the food that we eat so that we can be breaking it down, but when we break those hydrogens off, we use those hydrogens to then make ATP. ATP is the energy. That's how things get done in the cells. So if we're not able to pull the hydrogens off of the food that we eat, or the things that we need to break down to get energy from, we can't actually yield any energy from what we eat. And so one way that we do that is via transfer molecules. So, and the opposite side of that is true as well. If we're already fed, we have plenty of food, and now the body's trying to make other things, like make our hormones, make this, that, and the other, we need these transfer molecules then to provide those hydrogens to do the anabolic reactions. Okay, so we've got 3, there's actually 4, I didn't bother with FMN, it doesn't come up too much, just know that it's an example of a transfer molecule. We'll go into more details with these in terms of kind of breaking them down, but an overview of them is to say that NADH, I made the hydrogens in a different color so that they would stand out, because that's the point here, is where's the hydrogen? It's hot potato hydrogen. Where's the hydrogen? Wherever the hydrogen is, that's the reduced version of it. So these here, NADH, NADPH, FADH2, those are your reduced transfer molecules. So when they release the hydrogen, we have NAD+, NADP+, those are your oxidized versions of them, right? Because the reduced is the gained ones, they've gained the hydrogen, oxidized, have lost them. So basically, if you have an NAD, if you have NADH, if you have NAD plus can now receive a hydrogen that's being broken down off of our food products. So you go from NAD plus to NADH, and that NADH then is transferred to where it needs to go in the cell to help make the ATP. So that's why they're transfer molecules. The food that we're eating is being broken down, hydrogens are flying off onto these transfer molecules. Specifically with the catabolic reactions, we're thinking of the NADH. We'll break those down in another video, but I think that does it for the overview with just some terminology. My next video is going to be just covering that analogy, or the diagram I said I was going to draw to kind of explain how these things relate together in a visual picture.